Okay, so continuing with this question, we're up to part II. If the derivative is American style, should it be exercised earlier? What is its initial value? Okay, so let's take a look at this particular problem. The calculations from earlier. We're up to here. We're now considering American style options. Okay, so we're going to follow the same process as we did for part I. We're going to start with node B at the first time step, and we're going to calculate the payoff at this particular point and compare it with its value. So from part I, the value comes from the risk-free valuation, and we calculated that earlier as £5.21. So what's the payoff in this situation? Well, we can use the payoff equation, which is given in the question as this thing. So 5. Okay, and what's that? 2 is good for over 2 is £2 and 0 pence. So at node B, we have a value of £5 and the payoff is £2. So it makes sense not to exercise. So early exercise is not an option. You're not going to collect £2 for something that's worth £5.21. And we continue for node C and for node A. We have the risk-free valuation that we calculated earlier, which was £21.81, and the payoff, using the payoff equation, is equal to 6 squared divided by 2 is 18. Okay, so similar to before, we think it's worth £21.82, and we could get £18 for it. So we don't want to exercise. Early exercise is not an option. Okay, so that's the methods. Once you can do one or two, you can do them all. So node A, the value using the risk-free model, we calculated as £11 and 47p. This is what it's worth. How much can we get for it? Well, according to the payoff, we should expect to be written in the contract somewhere. The payoff for this situation would be £8. So again, early exercise is not an option. Okay, so there you go. That completes the second part of this question using these American style options. Actually, nothing interesting happened here. The European and the American payoff are identical. So let's take a look at the next part, which is III. So these calculations are quite long. Scroll back to the top. Here we go. What is the initial value of a down and out barrier call option with strike of 39, a barrier of 36, and they pretty much tell us what a down and out call option payoff would be. So let's take a look at that. So it's the strike price take away, the share price take away the strike price, which is in here. We only consider the positive value if it's negative, the market has moved in the opposite direction and we just don't exercise. How about this thing here? So for this equation, what it means is the output is 1 if the condition is satisfied. If the condition is not satisfied, then the output is 0. So this could be 1 or it could be 0. It's 1 if this condition here is true and 0 otherwise. So the condition says that if you look at the share price over this period, if the minimum is bigger than the barrier, 36, then the output is 1. Okay, so this is a down and out barrier call, and our job is to find the initial value of the call option using this idea. Okay, so let's do it. So the first thing we should do is build a probability tree or payoff tree or binomial tree, whatever you want to call it, for the options, for this option, given the movements in the share price coming from the question. Okay, sorry if this makes you dizzy. There's a lot of calculations here. Let's get through them. Okay, so like I just said, I'm going to build the binomial tree for the option with this particular payoff structure. Okay, so just the same as before, step 1, it could go up or down. I'm going to call them U1 and D1. Now we have the second step, so it could go up 2, following the U1, could go down 2, following the U1, or it could go up following the first down, or down following the first down. Okay, so now the payoffs. So we're going to use this special payoff equation, which is the following. So it's the share price, take away the strike, the maximum of this and 0, times this function, which is 1 or 0, depending on the minimum share price being above 36 if we look backwards. Okay, so let's take a look at the share prices and see if they fall below 36. Given that this particular situation, the share price is risen and then risen again, I don't think it's going to have fallen, but let's check it. So the share price is looking backwards. So the share prices, they're 48 now. In the past, they were 42 and 40. So they're 48 now. In the past, they were 42 and 40, and they haven't fallen below the barrier of, what was it, 36? Yeah, 36. They haven't fallen below that number. So the condition holds, the output is 1. Okay, whilst I'm here, I'll just talk about the other ones. So when we step down to the 40, when we look backwards, we have the 42 and the 40. Again, the output is 1. When we look here, the 42, if we look backwards, 38, which is above the barrier, and 40, which is above the barrier, output is 1. And finally, 34. The values we have 34, 38, and 40. And the 34, this is below the barrier. So for the final output, the condition doesn't hold, and we're going to have a 0 valuation. Okay, so that was my observation. Now I'm actually going to calculate them. So we have 40, which is the share price, minus the strike. The minimum share price should be bigger than 36. 42. Okay, I'm just going to write it all out because it's not really a standard calculation. We didn't see this much in lectures. Okay, so let's start at the top. 48 take away the 39 times by 1 is 9. 40 take away 39 times by 1 is 1. 42 take away 39 times by 1 is 3. 34 take away 39, well that's just 0. And times by 0, so that is definitely 0. And we have the values of the options at the second step. Okay, so now the usual process. I think I'm going to use some colors on this one because I've pretty much destroyed the previous binomial tree. So we're going to value this by looking at these branches. We're going to value this by looking at these branches. And finally, we're going to find the initial value by using those two pieces of information. Okay, so we have models here. Everything's in the formula sheet. So at point B, we have the following. Okay, and I'm not going to spell it all out. Okay, we're just dropping the numbers in. Let's just save some time here. This is £3.64. At this one, at point C, we have this one. Okay, and I've done this in the calculator already. And finally, at point A, oops, we're going to use these two pieces of information to get the final answer. The value, the initial value of the option, this was the question, is £2.86. And that completes question 1. That's a particularly long question, probably about half hour of work there, assuming that you know what you're doing. So take your time with it, take a look for those steps. It's all there for you.